Okay, so in this illustration, again, this is going to be for, again, a sigma. Let me make this a little bit thicker. This is a sigma unknown scenario with it's an unequal assumption of your population standard deviations, okay? And so I'm going to be illustrating this as number 13 in your textbook. It is a two-tell test. So just to kind of show you the basic idea here, it's in terms of the actual formula. So one sample size is N1, we'll say, is equal to 15. And then the other sample size is N1 is equal to 12. So I don't expect you to plug it into that crazy equation. So you can just approximate your degrees of freedom by simply taking 15 plus 12, which is 27, minus 2. If you just use 25 as your degrees of freedom, that's okay with me. Because, you know, when you set up your constraints here, if you look up the solutions manual, they're going to use a different degrees of freedom because they plug it into the crazy equation. But I would come up with using degrees of freedom of 25 and an alpha level of 0.05 being a two-tell test. I would get 2.06 versus minus 2.06 at that point. But then the actual formula would be, I'm going to write it way up here. So your test stat would be 50 minus 46, so there's your numerator, all over the square root of, so we'll do 5 squared over 15, because that's your sample 1, plus 15 squared over 12. Now notice, as you compare the two sample standard deviations, they are different. One is 5, the other one's 15. So there's where you kind of get into this unequal assumption. That's where they get that. But once you plug it into this equation, you're going to get about a 0.89 test stat. And of course, that's not going to be in a rejection area. But again, the basic idea here is, you know, I'm not going to make you do the crazy formula on the previous example with the degrees of freedom. For two populations, you can always use this formula for me. It's often said to be a good approximation of the degrees of freedom. But in this case, I think if you plug it into that formula, you get like 13 or something. But you're okay to use this on the exam coming up.